Good morning, everyone. My name is Elizabeth Vezina, and I'm the Fisheries Engagement and Field Program Lead for the Canadian Wildlife Federation. I'm going to discuss in this presentation results from our ropeless or on-demand gear trial program, which we've undertaken for the past 6 years. And as you'll note, I have changed our title to results from 5 years of trials, just because I won't be including this past year's results in the talk. As this work is still preliminary, we would appreciate if you do not share this via social media. So as many of you know, in 2019, we developed an evidence-based framework to evaluate on-demand gear for fisheries, and we did so in partnership with fish harvesters. For the past 6 years, we've been implementing this framework in at-sea trials and using results to provide feedback to developers in an effort to help the gear become more suitable for Canadian fisheries. An important note about our trial program is that trials are conducted outside of commercial fishing seasons to avoid impacts to the harvesters' livelihoods and to better focus on data collection. Harvesters are also compensated for their time and expenses when participating in the trials. We continue to improve this framework annually by meeting with our industry partners to discuss trial findings, maintain an open dialogue surrounding how we conduct the work, and to facilitate a sense of community between those who are participating in the trials. Early on, we identified 3 key conditions we wanted to adhere to in our trials to ensure accurate representation of how on-demand gear would be used in a fishery. First, we wanted to ensure all the components of a system were being evaluated simultaneously. Second, we wanted the systems to be trialed under fisheries conditions. Of course, not trialing during fishing seasons complicates this a bit, but we do ensure that we are trialing on fishing grounds and in various environmental conditions in an effort to evaluate the gear in as close to these conditions as possible. And lastly, we identified training as a key piece to the trials. There, of course, is a learning curve in learning how to operate this technology. So training is essential to limiting operational errors in the data, but we also acknowledge that it's impossible to eliminate all forms of human error. So we built the ability to identify these occurrences into the evaluation, which you'll see in the coming slides. A few years back, I presented a large table representing all of the things our framework initially identified as being important to evaluate, but over the past 6 years, we have further refined this to the 9 straightforward criteria you see here, as being the essential needs for an on-demand system to be suitable for a fishery. The systems must be detectable on the seafloor and have failure rates less than or equal to traditional gear. They should be simple to reset and functional under all relevant environmental conditions for a particular fishery. They should be quick and efficient and safe to use, durable, and they should stay in place once set. And of course, they need to allow the harvest of the target species. So once we collect data in the field to evaluate these 9 criteria, we categorize each deployment according to whether it was a success or a failure. And very simply, these definitions for us are that the gear worked and we could retrieve it acoustically according to the defined method, or that did not occur. So when systems do fail, we can identify why they failed in order to provide context to the issue and provide better feedback to the developers. Elements of a successful deployment can be imperfect as well, and we can also identify any variation in gear function to add context to these results as well. So for example, a successful retrieval could take 5 acoustic signals to recover, and we can identify that in the data rather than assuming that every successful retrieval has functioned without one of these variations. So we categorize variations into the following groups. Ideal for deployments that went perfectly, technological for something that goes wrong with the topside equipment, acoustic for an issue with the acoustic communications, mechanical for any problems with the physical release mechanism or the rope containment or lift bag. Operational is used to describe any human errors, and unknown, which could be a combination of issues or a deployment where the problem could not be identified. So jumping into some results from the 5 years of trials with 8 different systems, we have trialed a 9th system as well, but due to a limited sample size, that has been removed. So successful deployments are seen here in gray, with the other colors representing the variation categories of each failed deployment. And as I mentioned, the categorizations allow us to take a closer look at what the strengths and weaknesses of each system are. So for example, you can see here in system A that there is quite a bit larger operational category than the others, indicating that this system may have a larger learning curve associated with it, or maybe there are more steps that could be forgotten or performed incorrectly when using the system. Similarly, the large mechanical category here in System B could indicate that there is a significant pain point in the system that could use some further development, or perhaps several pain points that when combined are making the success rates lower. So here we're looking at the same data, but we now have failures in gray and the successful deployments categorized according to how well the gear functioned. It's useful to have these categorizations because it can inform improvements that continue to be made even with the systems with the higher success rates. And it can really help the developers to fine-tune their systems to ensure operation is as smooth as possible. So in this figure, we have the proportion of successes on the y-axis and year on the x, and the black points represent mean success rate with 95% confidence intervals. And we have modeled success shown in blue. So what we can see from this is that success rate has been trending in the positive direction over the 5 years of the program, and this can be attributed to several things: familiarity with operating the gear improvements over time, and removing systems from the program that were just not showing suitability for the fisheries we're dealing with. The fact that we don't see a large slope here is also informative and tells us that this technology is not overly complicated to learn, which is also indicated by our starting success rates, which are around 75%. So we're also collecting timing data when we're conducting our trials. This figure shows the time to surface relative to depth. We performed an analysis of covariance and determined that we had 2 groups of 3 systems each that had significantly different surfacing times. One group being just over a minute faster to surface at 30 fathoms, as an example. The remaining 2 systems were not significantly different from either of these groups. Time to surface, of course, can be impacted by several things, most importantly the buoyancy of the system and the weight being lifted to the surface, but other factors such as the time it takes for the signal to connect and the release mechanism to operate would play a role, as well as the current where the gear has been deployed, which we've been finding can have a significant impact in areas like the Bay of Fundy. Also important to note that we can't say that this would be straight time that we can just add to a harvester's day for each unit hauled. We know from fishermen's experiences with this gear that once they're used to it, they can signal on the approach to the buoy and have it reach the surface when they arrive to its location. This will also become easier, of course, as through-haul transducers become more widely used. This data can, however, inform harvesters of surfacing time for each of the systems and how to use the gear most efficiently during daily operations so that they're losing minimal time. So as you've seen at the consortium, we're not the only group conducting trials of on-demand gear. Here we compared 4 systems of our success rates with NOAA's data. 3 of the 4 systems that both organizations trialed showed no statistically significant differences in the success rates. And this points to both consistent operation of the systems as well as high reliability of the systems for varying fisheries and conditions. The one system here with a significant difference highlights that some systems may work well for one fishery and not for another, but given the unbalanced sample size here, this is data that we'd like to revisit. So we're now using our trial results to determine what systems we provide to harvesters for use in right whale closures in Canada. These criteria were developed from a combination of needs to meet our experimental license permits, a desire to have fish harvesters be successful in what is often their first exposure to this technology, and to ensure right whales are not put in harm's way. Some of these criteria are very unique to the CanFish program, as we operate as an emergency response to fisheries closures, limiting the time we have to adapt vessels to the gear and to train harvesters. So to conclude, we proposed a method developed with the fishing industry of trialing on-demand gear to evaluate its suitability for fisheries. Our results demonstrate that despite the perceived complexity of this technology, success rates and suitability are high for many fisheries, and data can be used to identify if there are any regions with particular challenges operating the gear. We've shown that success rates improve over time with training and improvements to the technology, and trials continue to be an important piece of on-demand fishery development by informing both lending programs and regulations with objective scientific evidence. I want to acknowledge the team of people we have working on this program, as well as our harvester partners and of course our funders. Thank you for listening, and I'm happy to take any questions. Thanks.